Hi, video people.
Okay, can you guys see that okay?
Okay. You're discussing people on the computer.
Excuse me. No, what you see up here is what they see. Excuse me. Okay. Can you see it in that I'm writing in pencil? Can you see the pencil? Okay.
Yeah.
Okay.
So the things that you need to know are the shell formula, and to be honest with you, because at this point we're just focusing on AB right now. BC would be a different story. Shells is not an AP topic. However, the advantage of shells is when you're rotating around the y-axis. Because if you're using the disk method, you have to rewrite the function in terms of y. And so when you're using shells, because the y-axis, you're going the same direct, like if the height is the x, you're going parallel, then you don't have to worry about rewriting it. So that would be the advantage of this case right here, when you're rotating around the y-axis. Okay? In other words, if we had time, which we probably won't today, I could do this with the disk method, and the way I would do it is I would rewrite this and write x equals 1 minus y. You following? I'd integrate from 0 to 1 and use the pi r squared formula. Okay. Question, Bray.
So on the test, are you going to tell us which way to do them, or?
I have one where I ask you to do with shells.
Okay.
Honestly, if you did it with, I think it's one that, if I remember correctly, it's a pain in the butt to rewrite it the other way. But if you wanted to, I would totally accept it. But my advantage would be, my preference would be to use shell. Next Thursday, Friday.
Next Thursday?
Thursday.
Midterm?
Right.
Okay.
But it's not a midterm.
Yeah.
Oh, you know what? I'm supposed to give a midterm.
No.
If you give a midterm, I will leave. And I will
Give a
not take
midterm.
the test.
I'm supposed to have
I will not take the test.
Okay, we'll talk about that. I'll look. I look at it. I forgot about that. Okay. Anywho, this is the formula. Okay, so just to review again, we're going to rotate this around the y-axis. So r of x is the radius, and the radius is how far it is from the center of rotation. So does that make sense that that's x? And h of x is how tall it is. So that's what I got for how tall it is, the function itself. And then I had this. This is where we left off, right? Okay, let's do it. So,
So I don't get the point, like, how you don't have to rewrite it. So if you're trying to do it around the x-axis, would it just be the same exact equation?
no. It would be the same equation, but because if I went around the x-axis, using shell method, if I went around the x-axis, shells go parallel. So that if I went around the x-axis, it would be like this. So to have the height, I'd have to rewrite it in terms of y.
They still have to rewrite it?
What I'm telling you is I would never use shells to rotate around the x-axis. I would use disk method, because disk method is in terms of x.
Okay.
There are different methods that will find the volume of the same solid, and sometimes there's an advantage of using the one over the other. So really my only point in this for you guys would be in a situation where it was difficult to rewrite it. Yeah?
So, since it's technically an approximation, would you get a slightly different answer if you did the two separate ways? Or would
Hey,
it be-
Bryce, let's do it at the end and see if we do.
Okay.
I don't think so. I think it will work.
Alright.
I'll do a quick, fast version at the end. All right, here we go. We're good with that. Let's distribute. This is going to be 0 to 1, x minus x squared, right? Dx. I just distributed that. And let's now integrate. There's a 2 pi in front. Because these are, we're doing like surface area of the shells. X squared over 2. minus x cubed over 3 from 1 to 0. We following that? Okay. Then if I put a 1 in, this would be 1/2 minus 1/3. And then this is minus 0, isn't it?
Yeah.
Okay. Common denominator, if I multiplied this by 3 over 3 and 2 over 2, I have 1/6 left. So 2 pi times 1/6 is pi over 3. Okay. Oh, what the heck, let's do it. If I were to use disk method, I'm going to squeeze it in at the bottom. The formula is the volume and then pi times radius squared, where radius squared is how far away it is from the y-axis. So if I was rotating around the y-axis, I would have to rewrite this function. Wouldn't it be x equals, I know you can't see that, 1 minus y, or negative y plus 1? Okay. I'd still be doing 0 to 1. And then I would have 1 minus y parentheses squared dy. You guys do not have to do this. I am showing Bryce, or we're checking if it's going to work, if I'm going to get the exact same answer this way. 1 minus 2y plus y squared crap. Gotta squeeze it in there. You guys checking my work? So this would be pi times, when I subtract the 0, it's just going to be 0. 1 minus 1 plus 1/3. Yep. In this case, I think it's just about as much as the same amount of work to rewrite. What you're going to see is where is one that I had? Oh, like I've seen stuff before where it's written in terms of y and it's like e to the y power, and that's like, that would be a pain in the butt. Or e to the x power. I mean, could you do it? Yes, but sometimes it's easier to integrate like e to the x than trying to rewrite it. So then you could use shells and leave it as e to the x rather than rewriting it in terms of y. Okie dokie, how are we doing so far? Alright, we should do one around the x-axis so you see how it works. So around the x-axis, remember, it's a little different. So we're going to go around like this, but we're going to use a shell. And so our shells are going to be these cylinders, okay? Oh, nope. Yeah, x-axis. See, now I'm getting confused. Yep. So these are going to be these cylinders, and we're going to be going around this way. I'm really bad at drawing them. And this would be my other cylinder, and then we rotate it around this way. Okay? And so when I'm coming up with my height of my cylinders now, they are written in terms of x, right? So I'm going to write this as 9 minus y squared. Are you all okay with that? Okay. So if you flip back to the beginning page, when we rotate around the x-axis, I have indicated that these are going to be written in terms of y. Their height is going to be in terms of y. So this is my height for each of these. What do you think the radius will be? How far are these away from my center of rotation? Y, whatever Y value it is, right? Okay, so my h of x is, or my h of y, sorry, is this, and my radius of y is just equal to y. Sorry, that's a messy y. Alright, here we go. So the formula is 2 pi. I'm going from 0 up to 3. And then I have r of y, which is y, times 9 minus y squared dy.
How do you get RY which is Y?
So this is a cylinder. Do you see this cylinder? The radius of this cylinder is how far it is from the center of rotation. So if the center of rotation is the x-axis, it's just going to be y. Do you remember on the other one it was just x? Because that's how far it was from the y-axis. Okay. All right, here we go. Let's do some work. So when I expand it, I get 9y minus y cubed dy. So let's see, that would be 9 halves y squared, right? And this would be minus 1/4 or y to the 4th over 4, and we're doing from 0. Yeah? I am really sorry. Thank you, Jobin, for pointing out. It should be 9 minus y squared, and I just put it in there wrong. Thank you for correcting me. It should just be 9 minus y squared. So it should like be, the square root is here. Because you're right, if it was 9 minus y parentheses squared, it should be 81 minus 18y, and so on. Okay. All right. How we doing? So the nice thing about this is when I subtract to 0, it's just going to be 0, right? Okay. So let's see here. 3 squared is 9. 9 times, this is 81 halves, isn't it? And then 3 to the 4th is 81 minus 81 fourths. This would be 162 fourths minus 81 fourths, right? Two goes into 4 2 times. Okay. Okay, in my humble opinion, once again, I think that possibly this would be, well, yeah, I think this would be a scenario where I would use just this method instead to go around the x-axis. Because it would be y squared equals 9 minus x, and then you do the square root, but remember, it's pi r squared. Okay, just saying. So far, each of these methods, it would be just as easy to have used this method. All right, let's take a look at a different axis because that sometimes throws us for a loop, okay? This time, I'm not going to be rotating around the y-axis. This time, I'm rotating around this axis, x equals 2. So what we're going to do is we have to figure out how high the shells are, and we have to figure out how far they are from the axis. Okay, so we're going to be going around this way. So one of our little shells then would be, you know, like here. I'd have this, and I'd rotate around.